Now that we've drawn up a workable entity relationship diagram, let's take a look at the specifics of some of these entities and start converting them into MySQL tables. First of all, we're going to look at the customer entity and try and translate that into a customers table. Customers table will have, first of all, an ID column, and the ID column will be the primary key. And this will be probably an integer and will be an auto-incrementing column. This will be a unique identifier for each of our customers. We'll also need a field that will store the customer's name. However, to store the name as one column, which is what I originally wrote down when I was sketching out the plan for this database, is not an atomic element of the customer's entity. It can easily be broken down into first name and surname. We can then add some personal details about the customers so that we can get back in contact with them. The customer's date of birth, this is a very important field or column because it allows us to make sure that we're renting the right kind of videos to the right ages of customers, to make sure that no children, for instance, are watching adult movies and so on. We also need a place to store comments that the employees can write about the customers. This translates very easily into a series of, well, a single SQL statement, create table statement, that creates a structure for the customers table. So that's our customer entity translated into a table. Next we're going to look at the films table, and again we're going to have an ID, which is going to be a primary key. We're going to have the title of the film, and we're going to include the film's genre, and this introduces the relationship between the films table and the genres table. So let's take a moment to draw up our genres table so we know that what we're relating to here. Our genres table will contain, again, an auto-incrementing primary key, and we're going to call that the ID column. We'll also have the name of the genre, and the link will be on the ID column of the genre and the genre column of the films table. So essentially an integer will be stored in the films table, and we'll be able to relate that to the genres table to get the name of the film genre. So our genres table, also very simply created, and that clears that one up for us as well. So let's get on with the rest of the columns of the films table. We're going to need a rating, and this rating could be, we could do this several ways. One way would be to have a ratings table like the genres table, which would store information about each of the different ratings. However, since ratings change relatively rarely, whereas it's quite possible that a manager of a video store will decide that they want to break down a genre into more specific sections, or that they want to combine two genres together, we can see that the two different kinds of data do not require the same treatment. Instead, we're going to use an enumeration column for the rating column. That's going to include the values general, parental guidance, mature, and restricted. Cost of the film, and the cost will relate to either $3 for new release or $2 for standard. And how we're going to affect that change would be, one way to do it would be to actually store the $3 and $2 figures within the films table. However, this is what I wrote down initially when I was sketching out ideas for the database. Very quickly though I realized that this would fragment the information. because if we wanted to increase the price of the new releases, or we wanted to decrease the price of the standards, or whatever we were doing, we would have to go in and edit every entry of a film stored in the database already. We therefore want to refer to the charges table so that we can quickly make changes to the charges that we're charging for rentals, late fees and so on, and we only have to make the change in one place, which will then be reflected across the board. We therefore move the relationship from copy to film, because when a film goes from new release to standard, all copies will reflect that change. So let's take a look at the charges table in which we're going to store that charge information. We're going to have an ID column and an amount, which is going to be the number containing the charge. This ID column is going to be rather different from the others because it's actually going to be an alphanumeric field, because we have a relatively limited number of charges, and it also allows us to keep the necessary information in the films table in a way that is evident. That's the charges table. Let's move on with the columns of the films table. We also need the year released. That will allow searching on a particular time in which a film was released. And here is the SQL to create the films table. As you can see, we have two ENUM columns, the rating column and the charge column, one of which relates to only a set of values, the other of which relates to the charges table. So that's our films table created from our film entity. Next we need the artist table and the film artist table. In the artist table, we're going to store an ID and first name and last name, similarly with the customers table. As I worked with the database a little more, I decided that I would combine the first name and last name to a single name field. This will allow us to simplify searching on a particular artist's name. We should realize that this is a denormalization because we've broken the principle of atomicity of data. However, as I mentioned in an earlier chapter, there are certain instances where denormalization can, if effectively used, be very helpful in our database design. This is one of those instances. So we're going to change the first name and last name to just a single name column. In film artist, the bridging table, we're going to store the film, which will relate to the ID column of the films table. We're also going to store the artist, which will relate to the ID column of the artist table. We're also going to have the particular job that the artist has done on the film. This will be one of three choices: actor, director and writer. As you can see, here are the two sets of SQL statements to create those two tables. The film artist table, the bridging table, has a primary key, and that is the film combined with the artist columns. So essentially we have a unique identifier in terms of the film and artist combination. We've also used an enumerated column type for the job done to ensure that we have strict control over the kind of jobs that film artists can be doing within our system. So there's the artist table and the film artist table completed. Now we're going to look at another central entity within the entity relationship diagram, and that's the copy. I'm going to translate this into the copies table. We're going to once again use an auto-incrementing primary key. That's the ID field. We're going to have a film column, and that's going to relate to the ID column of the films table. So that creates the relationship there. We're going to have a rented to column, and that allows us to at any time be able to see who the particular copy of the film has been rented out to. If it hasn't been rented out at the moment, in other words it's on the shelf, then this field will be null. We'd also include a rented by column so that we can keep track of which employee is renting to which customer and which film they're renting. We also need a date due back. Once again, all these three fields, the three last fields, will be null if the copy is sitting on the shelf. We also need format. This allows us to differentiate between VHS and DVD. This is what it looks like translated into an SQL statement. That's the copies table. Let's take a look at our employee entity, the final one. Here's employees. Here's our ID column, again a primary key. Some personal information about the employees. And a title column. This title indicates whether they are a boss or an employee. And I've chosen to call the employees droids, for no particular reason, other than the fact that the employee term is too generic, because even the manager is an employee within the shop. So in order to avoid any confusion, I've added the slightly facetious moniker droid to all the sales assistants. Here is the table in SQL form. As you can see, there's an enumerated field there, the title column, which allows us to select between manager and droid. So these are our tables that have been created from our entity relationship diagram. And in our next movie, we're going to start looking at the way in which this database design is used within our application.